Okay, so today we're going to continue talking about evolution. So far we've talked about the theory of evolution and how you have to have a lot of data and evidence to support a scientific theory. So for the past week, we talked about 9 pieces of evidence, okay? Before we move on, I just want to refresh. What are those 9 pieces of evidence? So go back, read your notes. Give me one.
Wait, can you say that again?
Fossil record.
Okay, the fossil record. We're going over the 9 pieces of evidence to support evolution.
Transitional fossils.
Okay, so the first one is the fossil record. Then we have transitional fossils.
Comparative biochemistry.
Okay, we have comparative biochemistry. Comparative anatomy. Homologous structures.
Comparative embryology.
Good. Comparative embryology. Good. Vestigial structures.
Biogeography.
Biogeography and
Evolution can be seen.
in like the context of bacteria and viruses, which is what we talked about yesterday. So now, those aren't evidence we use today to help support the theory of evolution. Back in Darwin's time in the 1800s, most of those weren't well understood, and Darwin didn't use those to develop the theory of evolution. Okay. Instead, Darwin centered his initial ideas around this concept called adaptation. So Darwin focused on adaptations, which are just traits that are shaped by natural selection, and they increase an organism's reproductive success. So in the word adaptation, do you see the word adapt? So think of adaptations, they're just traits that help these organisms adapt to their environment. And if they adapt well to the environment, chances are you'll survive longer, you'll be able to reproduce, and then you'll be able to pass those traits down to your offspring. So a huge key of evolution and natural selection is that you have to out-survive your competitors and you have to pass those traits on to your offspring. So we really look at your reproductive success. Can you pass those traits on to your offspring? We call that fitness. Okay, so when we talk about fitness, we're talking about reproductive success. And it's usually just measured by how many reproductively viable offspring an individual produces. So reproductively viable means can their offspring grow up and produce their offspring? Okay. Does that make sense? Like you could become a grandparent, if you will. And so we say the better an organism is adapted to the environment, the greater the chance of survival, the greater the chance of reproductive success, right? If I survive, I can have offspring. I'm going to pass my traits on to their offspring. Hopefully, they will also survive and keep on passing those traits through generations. How many of you have heard of the phrase survival of the fittest? Okay, so this is like a super popular phrase for Darwin. When you think of that initially, how many of you think it's like the most athletic or the strongest? And you think of like fittest in our terms of fit.
I think Hunger Games.
Okay, you might think Hunger Games. So when Darwin coined that term, it's survival of who can survive the longest and reproduce. Okay, so when he says survival of the fittest, he's talking fitness and can you produce offspring and keep your traits going. And then something I like to point out, a lot of times when you think survival of the fittest, you think it's like the best ever. Well, evolution doesn't have a brain, okay? There's no one out there selecting for the very best trait. It's really more like survival of the most okayest, because you might be in an environment where you have, let's just say, 2 animals competing for resources. Maybe they both just have like okay adaptations, right? Could there always be the potential for like a better one out there? So instead of it's like people kind of put this on the pedestal of survival of the fittest is like it's the very best variation that could ever have existed. And that's really not the case. It's just survival of the most okayest, whoever's the best at this given moment in this given environment. Okay. But I do want you to know,
Survival of the mediocre.
Pretty much. So when you do think of the term survival of the fittest, it's who can out-survive their peers, who can pass their traits on to their offspring. So it has nothing to do with like athleticism or surviving Hunger Games. It's can you produce offspring? Can you keep your traits going over the next generation? So now I want to talk about types of adaptations. I have just some examples to give you an idea of what do I mean. So one type is camouflage. Animals can develop camouflage, and we mean it in a biological sense, not like a fashion sense or a tactile sense. So camouflage is just a morphological adaptation, and it allows individual species to blend into their environment. If you blend into your environment, is that going to make it harder for predators to see you? Yeah, absolutely. If your predators can't see you, your odds of surviving go way up. And so then if you look at the pictures on the right, you can see some camouflage of different species, right? This one you can see, but it really blends in. This one, I think it's a little bug right here on my red dot. It's like a tiny little bug on some branches. And then here are turtles. You can see that they're trying to blend in. Another example is mimicry. If you're mimicking someone, what are you doing? Yeah, you're just like copying them, right? So mimicry is an adaptation when one species evolves to resemble or copy another species. And we see these traits survive when you take on the adaptation to look like even like a dangerous or a poisonous or like a bad tasting species. Okay. So you're going to look like something that your predator wants to avoid. So for example, does anyone know what these frogs are? Good. Poison dart frogs. One of these is the poison dart frog. One is a normal one that just mimics it. But would a predator know the difference? No. Nope. So the predator is going to avoid both. Here's just another example with butterflies. The monarch butterfly, it tastes terrible to predators. The viceroy butterfly tastes fine, but it looks pretty similar to that monarch butterfly, so similar that a bird is not going to want to take the chance and try to eat it. Another adaptation is just the one we talked about yesterday, antibiotic resistance or antimicrobial resistance. Okay. So over time, if bacteria can evolve some sort of trait that allows them to be resistant or not killed by antibiotics. And then finally, I just have a picture here of a polar bear. So we can just use this polar bear as all sorts of options for adaptations. So if you take a look up here, so polar bears, over time, they've evolved to have thick white fur. Okay, so the thick fur, it helps keep them warm, but it also camouflages them. The white camouflages them in the snow or ice caps. They've evolved a very thick layer of fat to help insulate them and keep them warm. Polar bears have huge paws. Almost think of it as like their personal snowshoe, so it helps them prevent themselves from sinking in the snow. They have tiny little ears that helps reduce heat loss, and then they have super sharp teeth to help eat prey more easily. So the adaptations we took on your notes, like the camouflage and mimicry, there are all sorts of adaptations. We're not limited to those. I just wanted to give you an idea. But any sort of trait that evolves that helps you adapt to your environment, any of those would be an adaptation.